Alright, so 1.3 is slope of a line. This gives us the following definition of slope. So slope of a line is the slope m of a non-vertical line that passes through points a, x1 and y1 and b, x2, y2 is m equals rise over run. If you guys remember, rise means you go either up or down, and run means you go left to right on the axis or on the quadrants depending on where you are. So the slope of a vertical line is not defined, and the slope is independent of which 2 points are chosen on the line. So you can choose whatever 2 points you like, and you will always get the same slope. Again, the key is you are consistent. Now, this is something I did with my Algebra 1 last year. It may help you remember if you have a hard time remembering slope. If you have a little guy that can walk up a hill, that's a positive. He can walk on top of a hill, that's 0. He can walk down the hill, that's a negative. But if he falls off the cliff, that's undefined. So that would be the vertical line. You'd be surprised, it's actually helped a lot of my Algebra 1 students when I taught it last year. So it's a good thing to remember if you're having a hard time remembering which one's undefined and which one's 0, the positive and negative slope. The slope of a line. So the figures in the box below show several lines labeled with their slope. So the same thing I drew earlier, but now in an actual coordinate plane. You have the positive going from left to right up, negative going from left to right down, 0, which is a horizontal line, and no slope or undefined. It's a vertical. If you guys write no slope or you write undefined slope, I would take either one as an answer. Just remember, 0 does not mean undefined. So if you put 0 for the slope, it would be wrong because 0 is a slope, but it's just a horizontal line. Finding the slope of a line through 2 points. They want us to find the slope of a line that passes through points P and Q. The slope formula is m, which stands for slope, is y2 minus y1 over x2 minus x1. Now, as long as you choose your 2's and your 1's to be, again, consistent, you will get the same slope. I'll show you. So for the first one, I'll choose P to be 2 and Q to be 1. So it's going to be 1 minus 5, 2 minus 8. So it's going to be negative 4 over negative 6. Simplifies to 4 over 6. Simplifies to 2 over 3. Now, if I would have done it backwards, Q being 2 and P being 1, I'm going to do 5 minus 1, 8 minus 2. I get 4 over 6, which simplifies again to 2 over 3, which gives us the same slope. So the key part is to be consistent with the points you choose. Not necessarily the order is going to matter. Now, there's another thing called point-slope form of an equation of a line. Point-slope form is an equation of a line that passes through the points x1 and y1 and has a slope of m. Now, when you're solving for a problem and you want to put it into slope form, your m is the slope, so you would use the y2 minus y1 over x2 minus x1. And then the other set of points, or a set of points that it's given, you would plug into the x1 and the y1. The y and the x that have no subscript are left the same. So the y stays the same, y1 is a number, m is a slope, x stays as x, and then x1 is a number. Now that will be from an order pair. Just make sure that you choose the same x and y from the same order pair. So if the order pair is 2, 3, make sure you keep the 2, 3. Don't choose another point for 1x and 1y. Again, consistency would be the key to this type of problems. So for example 2, they want us finding an equation of a line with a given point and a slope. Now, we have the point right here. So point 1 comma negative 3, and we have the slope of negative a half. So we're going to plug it into the equation y minus y1 equals m. x minus x1. So we're going to get y minus negative 3 equals negative a half x minus 1. It's going to become y plus 3. I'm going to go ahead and distribute that half into both terms to get negative a half x plus a half. I'm going to go ahead and actually, you guys can leave it like this. This is fine. If they were to ask you to put it into slope-intercept form, you guys will then subtract the 3 and combine it with the half. But this would be an equation that works just fine to get an answer. Now, if they wanted to just put it into slope-intercept form just to show you, which is what I was going to do, we would subtract that 3 on both sides. So y equals negative a half x. And then a half minus 3 is going to become 6 over 2. So we get negative 5 over 2 minus 5 over 2. So this would be slope-intercept form. Which is y equals mx plus b. That is the one you usually see. This is point slope. But both of those answers would be correct. Depending, obviously, if the question says leave it as a point slope, then leave it as the yellow. And if it says put it in slope-intercept form, then you move it to the green. Also, if you wanted to graph this, again, bear with me. I know this graph is not the best. You only need 2 points, really. You would put the points 1, negative 3, so right down here. And then we have a slope of 1/2, so we rise 1. And then we run 2. We rise 1, we run 2. I'm doing 3 points just because I don't really have a perfect graph. And it would look like that. Now, in Notability, you can use a graphing paper here. I just can't really bring in pictures. In the completed notes, there is a picture of a graph. That's how I wanted to also show you guys. Slope-intercept form of an equation of a line. This simplifies to y equals mx plus b, which is the slope-intercept form equation of a line. An equation of the line that has a slope of m and a y-intercept of b. So this is the slope. Again, if you needed to, you could find it by doing y2 minus y1 over x2 minus x1. And then the b is your y-intercept. That is somewhere along the y-axis that the graph will cross. So you could also graph it by plugging in the slope-intercept and moving on from there. We'll do an example of it in a minute. We have a vertical and the horizontal line. Vertical lines are just lines that are vertical anywhere on the graph. And then we have the horizontal lines that are just horizontal anywhere on the graph. Now, a vertical line, it's going to be written as x is equal to a number. Now, why is it x is equal to a number? Because it is on the x-axis that the x equals something. And then that x value is going to be the same no matter what the y is. And then for the horizontal one, we're going to get y is equal to, again, a number. Because on the y-axis, that is the only time that line will have a value. Because no matter what we have on the x, the y will be exactly the same. So we have vertical and horizontal lines. So an equation of a vertical line through 3, 5 is x is equal to 3. So like I mentioned, x is equal to a number. Number being the x value of that ordered pair. For b, the graph of the equation x is equal to 3 is a vertical line with the x-intercepts at 3. So if we draw a graph, we do 1, 2, 3. It's going to be a vertical line that passes through 3 the entire time. Then we have an equation of the horizontal line. 8, negative 2 would be y equals to negative 2. Again, the number being the y coordinate of that order pair. And then we have t, the graph of an equation y is equal to -2 is a horizontal line with the intercept at -2. So if we have this graph at -2, it would be a horizontal line right where y equals -2, because if we have any point, or we get any point in that graph, another point, it would still be 10, -2, 5, -2. So the y will give you the graph of this equation. So general equation of a line. We have proved the following. So general equation of a line, the graph of every linear equation is ax plus by plus c equals to 0, where a and b are both non-zero numbers. So that is a line. Conversely, every line in the graph of a linear equation. This is what's called standard form. So if you have a quadratic equation, it would be ax squared, or I'll give him some numbers. 2x squared plus 4x plus 3 is equal to 0. That would be a standard form equation. Again, in this type of lines, it's ax plus by equals to c. X being part of the slope, b being that y alone. So if you wanted to rearrange it into slope-intercept form, you can by first moving the c over. So it would be ax plus by is equal to -c. I'll subtract the ax, so it would be by is equal to -ax minus c. I'll divide by b, and we get y is equal to -a over bx minus c over b. So this means you can always rearrange this equation, slope-intercept form, into a standard form by multiplying the b, adding the ax, and adding the c, and just equaling everything to 0. So you can work backwards. If it's asking you to put it in standard form, just rearrange it. You guys should be okay with that. So we have parallel and perpendicular lines. So I'll fill in what's supposed to be here. We have parallel lines. I'll write the definition, and then I'll go over it. These are two non-vertical two non-vertical lines are parallel if and only if they have the same slope. We also have perpendicular lines. Again, there's two non-vertical lines are perpendicular if and only if they have the negative reciprocal slope. All right, so what does that mean for each one? Keywords right here are parallel and perpendicular. Just so you guys know, parallel can be written with two vertical lines like that, and perpendicular is just an upside down capital T. Perpendicular, remember, means 90-degree angle. Parallel means that they have the exact same line, the exact same slope. So, how do we know if a line is parallel? You can have an equation, for example, y equals 3x plus 2 and y equals 3x minus 27. These two lines are parallel. The only thing we care about to know when it's parallel is the fact that their slopes are the same. In this case, I just chose them to be 3 for both of them. That means that these two lines are parallel. Now, the only other thing that must be said is that they have different y-intercepts. So in this case, one's 2, one's negative 27. Why do they have to have different y-intercepts? If they have the same y-intercept, they're the exact same line. So different y-intercept is just going to put the graph, let's say this is one and then this is the other, in different places, and those lines are never going to touch. And now for the perpendicular lines, again, it's an upside down capital T for the symbol. What is the negative reciprocal? So I'm going to use the same equation, but I'm going to change one of the slopes into its negative reciprocal. Now, the negative reciprocal is this. Here we have a positive 3, and now we have a negative 1/3. So the reciprocal means that you put it into, you flip it. Remember, all the numbers, in this case 3/1, when we do the reciprocal, it's 1/3. But it has to be the negative, so we put a negative in front of it. If you have a fraction like 2/7, it would become negative 7/2, and so forth and so on. Now the key part is it's the negative reciprocal, so you do have to flip it over, and you have to make it negative. Now for the perpendicular, they can have the exact same y-intercept, because if, let's say, the y-intercept is right there, these two will make a perpendicular line because they form a 90-degree angle. Let me actually change the colors. I think that will make it easier to see. So they can have a negative reciprocal. They can have the same y-intercept. In this case, I didn't do the same y-intercept, but I can by just erasing the 7 and making it +2. It will still be true for a perpendicular line because they won't be the same line as they have different slopes. Example 7, finding an equation of a line parallel to a given line. So they want us to find an equation of the line through the point 5, 2 that is parallel to the line 4x plus 6y plus 5 is equal to 0. Now, I would recommend changing that equation into slope-intercept form. So I'm going to rewrite it. 4x plus 6y plus 5 is equal to 0. I'm going to start by subtracting the 5. And I'm left with 4x plus 6y is equal to negative 5. I'm going to subtract the 4x. So I'm left with 6y is equal to negative 4x minus 5. I'm going to divide everything by 6, and we're left with y is equal to negative 4/6x minus 5/6. That slope is going to simplify into 2/3. So we have y is equal to negative 2/3x minus 5/6. Now they're asking us to do a parallel. So we have the slope of the line. Our slope for our parallel line is negative 2/3. Now I'm going to go ahead and plug it into the point slope form. So I'm going to do y minus 2 is equal to negative 2/3x minus 5. Now, just so we can get it back to standard form, this would be an acceptable answer, but let's get it back to standard form just so you guys know how to do it in the case that you're asked to. You distribute the 2/3 on both sides, and we get y minus 2 equals to negative 2/3 plus 10/3. Now, I don't know about you guys, but I'd rather not have to deal with the fractions. I forgot the x for the 2/3x. So I'm going to multiply everything times 3. That's going to get rid of our denominator. So we have to distribute it to all of the terms. So we get 3y minus 6 equals negative 2x plus 10. The reason the stuff on the right said you don't multiply in times 3 is because the 3 on the denominator will cancel it out. If you do 3 times 2, you're going to get 6. And 6 divided by 3 is 2 again. 3 times 10 is 30. We divide it by 3 and we get 10 again. Now I'm going to go ahead and combine the 6. So I'm going to get 3y is equal to negative 2x plus 16. Sorry, not 16. Should be negative. Sorry, I made a mistake. It should be negative 10/3 and negative 10. So it's going to be -4. And then I'm just going to move the 2x over. So I'm going to get 3y plus 2x is equal to -4. I'll move that over and we'll get 2x plus 3y plus 4 is equal to 0. And we put it back into standard form. So you can always rearrange these equations and whether back and forth. Just make sure you don't make a mistake like I just did. I made a negative into a positive. At least I caught it. In the notes, the completed notes, I left it here. I don't know why. But it is good to know how to get it back into standard form. So we have these given points. -3,7 and 2,4. They want us to write an equation of a line parallel to and perpendicular to a line through the given points, -4.5. The first thing I'm going to do is going to get the slope. So I'm going to choose these to be my 2's and these to be my 1's. So I'm going to do 4 minus 7, 2 minus -3. So I'm going to get -3 over 5. That is our slope. For a parallel line, it's going to be y minus 5 is equal to -3 over 5, x minus -4. So it's going to simplify to y minus 5 equals -3 over 5, x plus 4. I'm going to rearrange it into slope-intercept form, just so you guys also get the y-intercept. Based on this question, this answer is more than correct. But I want you to keep going so at least you're able to find the y-intercept and understand how that works. To find the y-intercept, we will distribute that -3 over 5. We'll get y minus 5 is equal to -3 over 5x minus 12 over 5. Again, actually, I'm not going to do that. I'm going to add the 5 on both sides. So I'm going to get y is equal to -3 over 5x. Now, 12 over 5 plus 5 is not doable until I make this into a 25 over 5. Now this is doable. So now I get a positive 13 over 5. So 13 over 5 is your y-intercept. -3 over 5 is your slope. Again, this would be in slope-intercept form. And the blue one is in point slope. We're going to do the exact same thing for the perpendicular line. So we're going to do y minus 5 equals, now the negative reciprocal is going to be positive 5 over 3. X minus -4. This is going to become y minus 5 equals 5 over 3. X plus 4. So y minus 5 equals 5 over 3 plus 20 over 3. I'll then go ahead, again, this is fine for point slope. I'm going to get the y-intercept. So then I go ahead and add the 5, and then we get y equals 5 over 3x. And again, I can't combine them until I make this a 15 over 3, which gives us a 25 over 3. So here we have slope-intercept and point slope. The y-intercept I am highlighting in red for both. And we have a parallel and a perpendicular. So example 8 says, show that the points P, so 3,3, point Q, 8,17, and R, 11,5, are vertices of a right triangle. Now remember, a right triangle has a 90-degree angle. So if we find a negative reciprocal for one of the 3 vertices, for the slopes, we should be more than fine. Now, I'm going to name this, I don't know, P, Q, R. So we can find the slopes of the line of PQ, the slope of the line of QR, and the slope of the line of PR. Now, the reason I'm showing it in a triangle is because it'll make it easier to understand what lines to find the slope of. because if this slope of this line and this one, based on the way I drew the triangle, I don't know if that's going to be the right one, it's going to be a 90 degree. It could as easily be in the slope of another line. It's just the way I drew the triangle in this case. So let's find the slope for PQ first. The slope for PQ, I'm going to choose Q to be my 2's and P's to be my 1. So it's going to be 17 minus 3, 8 minus 3. It's going to be the slope of 14 over 5. All right, cool. All right, now we're going to find the slope of QR. I'm going to choose R to be the 2's and Q to be the 1's. So it's going to be 5 minus 17, 11 minus 8. So it's going to give us a slope of negative 12, 3, which is going to simplify to a slope of negative 4. If you prefer to write it as negative 4 over 1, that's fine. I'm just going to write negative 4 for the time being. And then I'm going to find the slope of PR, which is the line that I have left. I'm going to choose R to be my 2 and P to be my 1. So it's going to be 5 minus 3 and 11 minus 3. So I'm going to get 2 over 8, which is going to simplify to 1 over 4. Now notice how negative 4 and positive 1 over 4 are negative reciprocals of each other. So I'm going to write that in. So negative reciprocals means that it's perpendicular. That means it has a 90-degree angle. So therefore, yes, this is a right triangle. Remember, right triangles are not always drawn perfectly like the way I drew them. Sometimes they look like this, with the axis like that. They're not necessarily always going to be a straight line. That's how we found the slope for all of them. It just happened that these two are perpendicular, so we just proved that this was a right triangle.